The internet is overheating. Right now, on Earth, the AI revolution is hitting a wall. We are running out of land, our power grids are failing, and modern superchips are getting so hot they require oceans of water just to keep running. But what if the solution wasn't on Earth at all? What if the ultimate cooler was the vacuum of space? Today, we're looking at why Google, NVIDIA, OpenAI, and other tech giants are leaving the planet to build the data centers of tomorrow and the trillion-dollar race to control the orbit. Data centers is the backbone of the modern digital economy, powering everything from cloud computing and AI to e-commerce and remote work. They handle massive data storage, processing, and transmission, ensuring seamless global connectivity. Data centers drive innovation by providing scalable infrastructure for startups and enterprises, enabling rapid deployment of technologies like AI and IoT without heavy upfront costs. They support economic growth across sectors such as healthcare, finance, and entertainment by facilitating real-time analytics and secure data exchange. Disadvantages of data center. Data centers, while vital, come with notable drawbacks that challenge sustainability and efficiency in the modern era. Data centers consume enormous electricity for cooling and servers, accounting for about 1 to 3% of global power usage, straining grids and increasing carbon footprints. This demand often relies on fossil fuels in regions without renewables, exacerbating climate change. Data center power consumption was already significant and growing steadily around 12% annually since 2017, consuming about 1.5% of global electricity, 415 terawatts in 2024. Cooling systems contribute to water scarcity through evaporation, with some facilities using millions of gallons daily. E-waste from frequent hardware upgrades poses disposal challenges, releasing toxins if not managed properly. Some companies are trying to mitigate these issues by building space-based data center. How to solving these issues? The important driving forces behind tech giants exploring space for AI data centers is energy demands, cooling challenges, and land limitations are emerging as the key factors. Energy efficiency is a primary driver, with endless solar power and space offering a compelling advantage, and no carbon emission like in Earth. And in Earth need to get a large number of government approval. And AI data centers face severe cooling challenges due to the extreme heat generated by high-density GPU clusters powering intensive workloads. Modern chips like NVIDIA H100s draw over 700 watts each, pushing rack densities to 40 to 120 kilowatts, overwhelming traditional air cooling systems. Air cooling struggles with uneven airflow, hotspots, and high fan energy use beyond 40 kilowatts per rack, risking hardware failure and inefficiency. It consumes excessive space for ducts and fails to scale for AI's parallel processing demands. While more efficient, liquid systems demand high upfront costs, leak prevention, pipe maintenance, and corrosion risks in complex setups. Power grid instability and water scarcity further complicate operations, especially during heat waves. Data centers have increased water scarcity in multiple drought-prone regions worldwide, primarily through evaporative cooling systems that consume millions of gallons daily. Locations like Arizona, USA, Texas. Temporarily, to mitigate this issue, companies like Google, Microsoft are building data center in India. Due to land, power, climate issues, some companies trying to build underwater data center like Microsoft, and some Chinese companies to mitigate the above issues. SpaceX is the main reason for every tech company focusing on space data center. SpaceX drastically reduced rocket launch costs primarily through reusability, Falcon 9, heavy landing, and rapid reuse. mass production, and vertical integration, cutting the price per kilogram to orbit from tens of thousands to around $1,500 to $5,000, and aiming for as low as $250 to $600 with the fully reusable Starship, revolutionizing space access by making it cheaper. NVIDIA-backed startup StarCloud launched its first data center in space via a SpaceX Falcon 9 rocket on November 2, 2025. Google Project Suncatcher, a research initiative to place an AI data center in space to consume continuous solar energy, will launch its first test satellite around 2027. Several major technology and aerospace companies are actively planning and developing space-based data centers to meet the immense energy and cooling demands of artificial intelligence workloads. Key players include tech giants like Google, SpaceX, and Blue Origin, as well as several startups. Major global tech companies like Google, Microsoft, and Amazon are heavily investing in AI data centers in India, with massive commitments totaling tens of billions of dollars by 2030 to build massive AI-ready infrastructure, signaling India's growing role as a global tech hub for AI and cloud computing. Google alone committed $15 billion to build an AI data hub in Andhra Pradesh, focusing on cloud and AI infrastructure. Microsoft is $17.5 billion for AI and cloud infrastructure by 2030, its largest Asian investment. Amazon, AWS, announced a $35 billion investment. Is space data center the main objective?